Hi, I'm Paul Battaglia, and this is section 5.3, solving trigonometric equations. You know, there's a lot of things we can do in order to get students to see all the variety of trig equations there are to be solved, but there's actually, I'll say, somewhat of a sneaky way that maybe we can get them to see that they're actually solving an equation without even understanding that that's what they're doing. And for that, I'm going to go to Gabe and Brittany, and they're going to tell us a little bit more about the different types of equations that are out there. But Gabe's going to start us off with that sneaky way. So Gabe, go ahead.
So I like to use the beginning of this section to review a couple things that we've already talked about.
Okay.
So I bring up probably the unit circle, put it on an overhead or put it on the projector. Sure. And I also like to maybe just talk about the period of sine and cosine, just to begin, just to refresh some of these notions that students have. And where I go from there is I might phrase the question, okay, so for which angles is sine equal to maybe 1/2?
Okay.
And what this does is this sort of introduces the idea of a trigonometric equation without actually showing them an equation. Right. Because that could be a little intimidating.
Yeah, and you use that word equals, so right away, there we are, right?
Yeah, so really I just want them to look at the unit circle and maybe say, oh, well, sine of theta is 1/2 at pi over 6 and at 5 pi over 6. Okay. And then from there, we'll take the conversation a little further and I'll say, well, it's not just 1/2 at only those two angles, but at any of the angles which is coterminal to either of those. Right. So we might start at pi over 6, add 2 pi, add 4 pi, maybe start back there and subtract 2 pi, and the same thing for 5 pi over 6. Okay. And really what they're doing here is they are solving a trigonometric equation. They're solving sine of x or sine of theta equals 1/2, and they don't even realize it. So that when I transition from there into actually writing down an equation and asking them to solve it, it smooths that transition a little bit.
Yeah, no, I agree.
I like to use problems that you can still use the unit circle to double check. Yep. Just using those numbers and values.
Yeah. Talk to us a little bit about the kind of the next level of problems you would go into, right? What would you present them with?
I might present them with something with a couple of signs in it, just so that way they have to move things over and then solve for it, just getting them warmed up.
I agree. I think what you want to do with your students is get them used to the idea of isolating the trigonometric expression on one side. Really try and make that connection to previous algebra where you're trying to get the variable on one side and the numbers on another. So
exactly.
You know, I think that's helpful too. I think one of the other things that we kind of want to talk about sometimes with students is we progress from basic equations, let's call them first degree trig equations, if you will, to second degree trig equations. So let's just talk specifically about using the technique of factoring, right? I find these types of equations to be pretty useful for at least showing students the multiple solutions that could be out there. So you have options as a teacher. So one of the things you could do is ask your students to give you all the solutions that are possible. And if that's a little bit too much up front, then maybe you would restrict the solution set to maybe 0 to 2 pi or something of that nature, right? I think the one thing you want to point out, though, is if we are, let's say we're factoring a second degree trig equation, it is possible that we have 4 solutions inside 0 to 2 pi. It's also possible that one of the factors may not yield a solution at all. You know?
Or none of them might yield.
That's it, right, exactly. You could have no solution. So I think what we're trying to get students to see here is that, yes, when you're solving an equation like other equations out there, you may have a solution and you may not, right? Let's finish up with this. Gabe, talk to us a little bit about how we can then progress to a higher level and deal with multiple angle equations. Like, let's suppose we had, cosine of 3t equals 1. You know, how do we tell students to handle that?
So that's a great one to think about. So really what we're trying to do is we're trying to solve for this value t.
Right.
So we have this 3t, we have this cosine, we have this 1, we have all these things going on in this problem. And what I like to do is maybe take this back to the unit circle. So I'd say, well, for what values is cosine of just an angle theta equal to 1?
Right. So and taking the 3t out of the mix for a while.
Don't even worry about this 3t for this moment. And then what they'll do is they'll look at the unit circle, they'll say, oh, well, on the unit circle it's 0 and 2 pi if it's also on there. And then as you add and subtract multiples of 2 pi, you're getting all these values for which cosine of theta is equal to 1. And then I take that back to our problem. Cosine of 3t equals 1. So I say, well, in this case, the angle that we were talking about wasn't just t, but instead it was 3t.
Got it,
So what we have to do is we have to find, well, when is 3t equal to a multiple of 2 pi? Well, how do we solve this? We just divide each side of the equation by 3, and we have t is the 2 pi divided by 3.
Awesome.
Or 2 pi n divided by 3.
Right, exactly. Perfect. I hope these tips have been helpful for you and you find much success in section 5.3.